D is the right option. 6 cars waiting to be repaired at a car repair shop. Each has first to be dented and then painted. The estimated times for each car are given below. So here are the estimated times for denting time and painting time in hours. So here we will have to each car has to be first dented and then it has to be gone for painting. So next here we will have to find out what is the sequence of the car that minimize the make span. So to get the minimum make span, we can use Johnson's algorithm. So which gives in a table we can write it as, so we have 6 cars. Let us take 6 columns, 1 2 3 4 5 6. Okay, so in Johnson's algorithm, first we will have to take the minimum value on the in the table in either denting time or painting time. So if the minimum value in the denting time, we'll have to start from the left side, and if the minimum value in the painting time, we'll have to start from the right side. So here in the given table, the minimum value is 1. That is sixth car has the minimum denting time, that is 1. So here it is in the first column, or the denting time is nothing but the car has to be dented first. So that we will have to start this from left side, that is the 6th car has to be started from left side. So just strike off this and now go for the next one. So next minimum value is here 2. 2 is the minimum value in the table, but 2 comes in 2 comes for 3 cars. One is for third car, that is denting time is 2 hours. Another one is for second car, that is painting time is 2 hours. And another one is for fifth car, that is here also painting time is 2 hours. So as per the Johnson's algorithm, first consider denting time 2 hours for the third car. So which has to be came to the next to the 6, that is 6 3. So another two small values are for second and fifth car. So here for the fifth car, 2 hours for the painting time, or for the second car also 2 hours for the painting time. So it has to came, it should come from the right side, either 5 or 2 we can write it here. So let us say here 2 and 5. Now the remaining 2 columns are 4 and 1. So in the 4 and 1 columns, the minimum value is 3. Okay, and it is for painting time. So it will come from right side again. It is 1 and remaining is 4. So here 6 3 4 1 5 2 is the one option, or 6 3 4 1 2 5 is the other option. So in the given options, the right answer is B. B is the right option for the this question. Following list 1 and list 2. Here list 1 consists some terms, that is limit, speed, tolerance, allowance, deviation. So there are some definitions in list 2. So just match these two. Here limits matches with the definition. Third, that is prescribe difference likewise the dimensions of making parts to perform specific function, that is P is 3. And coming to the Q, it matches with 4. The Q is refers the range of permissible variation in dimension of part. And coming to the R, it matches with 1, and S matches with 2, and T matches with 5. So in the option, the right option is C. C is the right answer.
Air standard cycle in which the air enters the compressor at 1 bar and 22 degrees centigrade. The pressure of air leaving the compressor is 4 bar and the temperature at turbine inlet is 600 degrees centigrade. Here it is a common data question. It consists 2 questions. The first question is, what is the efficiency of the cycle? And the second question is, find the temperature of air leaving the turbine. So here it is a gas turbine cycle, and in the gas turbine cycle, thermal efficiency of the cycle is given by 1 minus 1 by Rp power of gamma minus 1 by gamma, where Rp is the pressure ratio, that is P2 by P1, and Gamma is the compressor process index or expansion process index. So here Rp is equal, P2 is the 4 bar and P1 is 1 bar, which is equal to 4, and here gamma is 1.4 for the air standard cycle, so that the efficiency of the cycle is given by 1 minus 4 power of 0.4 by 1.4, which gives a value of 32.7, 0.327, that is 32.7%. So in the option, the right option is B. B is the right answer for the first question. And coming to the second question, we will have to find out the temperature of the leaving air that is leaving the turbine. So here already we know that the inlet temperature of the turbine, that is equal to 600 degrees centigrade. Let us say this is a value of 600 degrees centigrade of T3, which is equal to 873 Kelvin. Now we will have to find out T4. So in an air standard cycle, that is in a gas turbine cycle, the expansion process is given by, is generally a reversible adiabatic process, and in reversible adiabatic process the relation between the temperature and pressure is equal to T3 by T4 is equal to Rp power of gamma minus 1 by gamma. So from this equation we get here T4, that is the temperature of the air leaving the turbine, so which is equal to T3 by Rp power of gamma minus 1 by gamma, which gives a value of 1.485, and T3 is 873, and it is equal to 587.4 Kelvin. So in the option, the right option is D. D is the right answer for the second question. Velocity 0.8 Pascal per second and specific gravity 1.2 flows through a horizontal pipe of 80 mm diameter. The pressure drop in 100 meter length pipe is 1500 kN per meter square. So here it is a common data question. It consists of two questions. So here the first question is the rate of flow of oil in meter cube per second is. So here the options are 0.032 and 0.0188, 0.063 and 0.093. And coming to the second question, the wall shear stress in Newton per meter square is. So coming to the solution, so we know that the average, here we will have to find out that the rate of flow of oil in meter cube per second. The rate of flow of oil is given by the average velocity into area of the pipe, cross-sectional area of the pipe. So here we will have to find out the average velocity, and is given by r square by 8 mu minus dou p by dou x. So here first we will have to find out dou p by dou x, or we can directly substitute the dou p by dou x value, that is the change in pressure or pressure drop in over a length. That is here it is already given, the pressure drop in 100 meter length pipe is 1500 kN per meter square, and diameter of the pipe is 0.08 meters, and mu, that is viscosity, is given by 0.8 Pascal seconds or Newton second per meter square, and specific gravity is given by 1.2. So now substitute all the values. Here R is equal to 0.04 square, and oil of viscosity is 0.8, and here minus dou p by dou x, that is the pressure gradient, which is equal to 1500 by 1510 cube by 100 meters. So which gives a value of 3.75 meter per second. Now substitute this value in the flow rate, that is 3.75 into pi by 4 d square, where d is the diameter of the pipe, that is 0.08 square, which gives a value of 0.01885 meter cube per second. So in the option, the right option is B. B is the right answer for the first question. And coming to the second question, so we'll have to find out the wall shear stress, that is the maximum shear stress. Maximum shear stress. Here wall shear stress is nothing but the maximum shear stress, and is given by minus dou p by dou x into r by 2. Just substitute all the values. R is nothing but the maximum radius, that is the radius of the pipe, that is equal to d by 2, 0.04. So which gives a value of 300 Newton per meter square. So in the option, the right option is A. A is the right answer for the second question.